Greetings everyone. Today we're going to explore how to graph linear inequalities. So we're going to use our slope-intercept form, our point-slope form, standard form. We're still going to be counting our slope, our starting point, our y-intercept, all of those things we have been spending time on. But now we're going to add two little elements that we need to keep track of. All right, if you have your foldable, you should be able to just fill in the blanks for these. If you don't, add them to your notebook and just pause when needed. So first, let's identify some steps, sort of a checklist, if you will, just in case you need it. So the first step is to graph the line. This is old news. This is what you guys already know how to do. If you're struggling with this still, make sure you look back on previous lessons. Here's what's new, okay? The first new thing is your line when you connect your dots is either going to be solid or dashed. And here's how you tell. If it's just a less than or a greater than, it's dashed. If it's less than or equal to or greater than or equal to, then it's solid. Here's the shortcut. Here's how I always remember it anyways. I feel like it's a shortcut. If there's a solid line underneath, it's a solid line, just like equals, right? Equals has solid lines. If it has a solid horizontal line, it's solid. If it's missing a horizontal line, then it's dashed. The third thing that's going to take the most work is we're going to shade using a test point, okay? So this means we're either going to color in above the line or below the line, or to the left or right, depending on your line. Okay, key thing on number 4 here is we need to remember, this is from a while ago when solving inequalities, you flip the sign if you divide or multiply by a negative. So jot that down, but here's what we're talking about. Remember when we had like negative 2x less than 10? If I divide both sides by negative 2, I'd have x, I'd have negative 5, but I have to flip the sign. That's what we're talking about, going back to those solving days, okay? And one little thing, don't forget about how horizontal and vertical lines work. Meaning horizontal lines are always going to be y equals a number. So that's going to look a little different. Now it's going to look like y is less than a number, for example. And vertical lines are always x equals a number. So now it might look like x is greater than a number. All right, let's look at some examples. These boxes and stuff are on the foldable. So if you don't have the foldable, don't make the boxes, just make little notes as needed and pause as needed. So the first thing we're going to take a look at is I need to graph the line. So I'm going to plot points. Let's start off. This is in y equals mx plus b form. So let's identify the parts. M. My m is in front of the x value. It is a negative 1/2. Therefore, my rise is negative 1. My run is 2. My b value, or my y-intercept, is a positive 3. So let's plot our points. Y-intercept is my beginning. Remember, beginning. I'm starting the y-axis at 3. My slope, my move, M can stand for moving. I move from that dot. I rise negative 1, run 2. Follow my dots. Rise negative 1, run 2. 5 are filled, so I'm going to go the other direction. Rise 1, left 2. Rise 1, left 2. That's old news. What's new is we need to decide if this is a solid or a dashed line. Look at your symbol here. This is a greater than symbol, so it's a dashed line. So as I graph, make sure I can see breaks in there. Okay, dashed line. And then here's kind of the tougher new stuff is shading. I'm either going to shade this little area above the line or all below the line. So here's where I got to do some work, okay? So we're going to use what's called a test point. The easiest test point to use, if you can, is 0, 0. Why? Because calculations are always easier if you use 0. You can use any point in the whole world, but 0, 0 is going to be your friend. So what that means is instead of x, plug in a 0. Instead of y, plug in a 0. So I'm going to look at my inequality. Instead of y, a 0 greater than negative 1/2. Instead of x, 0, and then plus 3. Well, what's 0 times anything? 0. Bring everything else down. What's 0 plus 3? 3. Now, here's the question. Is 0 greater than 3? No. False. Bad. However you want to refer to this. This is not true. Okay? However you want to think about it means that this test point is bad. I don't like it. I don't want it. That means my only option is to shade the entire other side of my line. And you want to fill the entire graph that you're given on that side. So if you had a 10 by 10 graph, I'd need to see a little more shading. All right, let's try this again, but this time notice my inequality is in standard form. I have to do a little bit of work. I need to isolate y first, okay? Which means I need to minus 1x. Now, I can't actually subtract 1x, so I'm just going to write 8 minus 1x. I then need to, instead of timesing by negative 2, I need to divide by negative 2. Divide everything. What you do to one, you do to all. So here's my new inequality. I'm going to write over here. I've got y. Careful here. I divided by a negative. So what do I have to do? Flip the sign. Okay. 8 divided by negative 2 is negative 4. A negative 1 divided by negative 2, that'd be positive. And 1 doesn't divide by 2. So let's just leave it as 1 over 2. And then don't forget your x, okay? Let's identify the parts here. This is all old news. If you need more practice on isolating y, see my previous videos. My m value is the number in front of x, so that's 1/2, which means my rise is 1, my run is 2, because it's rise over run. Then my b value, or my beginning, is the other number, which is negative 4. Let's plot. My beginning is at negative 4. It's my y-intercept, remember? From there, I need to count my slope. Rise 1, run 2. Rise 1, run 2. Can't keep going, let's go the other direction. Down 1, left 2. 5 are filled. In this case, I filled my graph as far as I can go. Next, I need to decide solid or dashed. So if I look at my inequality, it's a greater than symbol, so it's going to be dashed. So let's show a dashed line through my dots. Next, I need to check which side I should shade on. I'm going to use a test point. Again, you can pick any point. I'm sticking to 0, 0. And I'm going to plug it into the original function. Go back to the beginning. Let me rewrite it in case you need to see it again. This is the beginning, the original. Use the original because it's going to be easier actually. Instead of x, put a 0. Instead of y, put a 0. What's 1 times 0? 0. What's 2 times 0? 0. What's 0 minus 0? 0. See how nice that worked out? So now I need to decide, is 0 less than 8? Yes, true, positive, good. I mean, whatever vocab word you want to use. If it's good, that means I want to keep it. So I need to shade everything on the 0, 0 side. I'm shading above the line. Think about that. Greater than, above. Those words kind of sound like they go together. All right, let's take a look at this last one in point slope form. Again, if you need to pause, please do so. But let's work on identifying the pieces. All right, so let's start off with our m value. Our m is 1/3. Therefore, my rise is 1. My run is 3. And starting point, remember SP from the previous lesson, starting point, it says minus 2, so I need to write positive 2. It says minus 3, I need to write positive 3. So let's graph. Let's start with our starting point is at 2, 3. There's my SP. I'm going to count rise 1, run 3. Oop, I ran out, so I'm going to go the other way. Down 1, left 3. Down 1, left 3. It's a positive sloping line because it's a positive 1/3. But now I need to decide solid or dashed. Solid, because there's a line under it. It's or equals to, which means I draw, oops, hopefully a better line than I got there. Okay, a solid line through with arrows on the end. I wish I could just erase that one piece. That was bad. Fix that for me on your notes, okay? All right, checkpoint though. Here's where I need to show a little work. For my checkpoint, I'm going to use my original equation, and I'm going to use 0 for my test point. Test point, 0, 0. It's right here. It looks good. It's not on the line. All right, let's plug in 0 for y, and let's plug in 0 for x. Let's deal with that left side. What is 0 minus 3? Negative 3. I'm going to do parentheses first with 0 minus 2. Negative 2. All right, I'm going to keep that left side, but this right side here, this actually becomes negative 2/3. Okay? Either way, think about it. It's a fraction. If you use your calculator, you would get something like negative 0.6 repeating. That's fine for now. I mean, this is just side work here. Is negative 3 greater than negative 0.66? No, negative 3 is smaller. Like, I have less money if I'm in the whole $3. So this is false or no or bad, however you want to write it, okay? Meaning 0, 0 is no good. I don't want 0, 0. So I have to shade above the line, okay? To summarize what that means, all of those dots in the shaded area, every dot I could possibly draw in the world in the shaded area would be true in my equation. All right, so just to quickly summarize everything, remember you have to draw your line. This is all previous information. See my other videos if you need help. First, a new piece of information, solid or dashed. Does it have a line under it or not? And then shading. Remember, we're going to use test points. Here's where I'm going to see a little work. What's your test point? Which side are we going to shade on? All right. If you have questions, please let me know. Send me an email or a message if there's anything I can do. And until next time, I hope you have a good one.